standard equation for our intercept form is going to be y equals a times x minus p times x minus q. So on Friday, I started talking about these a little bit, and I said we'll talk about it later. So let me write these out. Okay, so if I write that out, right, roots, zeros, intercepts, solutions. All four of those terms actually mean the exact same thing. So when you think of roots, what do you know about roots? And I'm not talking about like the awesome band, but like where are roots? In the ground, right? So if I were to turn the world into an axis, is the ground going to be a horizontal axis or a vertical axis? Horizontal. So for us, roots are where the graph crosses the horizontal axis. Okay, when we say zeros, we're implying y equal to 0, which means we're on the horizontal axis, correct? Intercepts, these are actually x-intercepts, and then solutions. So all four of these terms mean the same thing. And what they mean is, where does the graph cross the x-axis? Why that matters is that tends to be where important things happen. So in actual application, we tend to focus on two key areas, x-intercepts and vertices. So where is it reaching its max? And then what's happening when it hits 0 again? What is going on? That's what we really care about when it comes to most quadratics applied, because we deal with real world, right? Where 0 is usually the ground or a person or a place. So once it hits that, we really don't care. So I just want you to know that these four words mean the same thing. And again, why would I go through this? The ACT. In one question, they'll say, find the roots. And then in the next question, how many zeros? And then they'll say, find the x-intercepts. And if you don't know the connection, your brain's going to be like, wait, we didn't talk about roots in class. Yeah, we did. We called them solutions. Okay? So if they say, how many roots does the quadratic have? All I'm asking is, how many solutions does the quadratic have? How many zeros? The four terms are all interchangeable. Okay, so the main thing is that you get past the language barrier. So when you're taking the ACT and you see the word solutions, intercepts, zeros, or roots, your brain can go, oh, wait, that's where do we cross the x-axis? And that's all I'm trying to find. Okay? Shape. How many x's do you see up here in our general equation? 2. What are we doing with those two x's? Are we adding them, subtracting them, multiplying them, or dividing them? Multiplying. So what's an x times an x? X squared. If the biggest power is 2, what's its shape going to be? A parabola. So again, we still have parabolas. All right, the vertex. Anybody know how to find the vertex in intercept form? Nah? All right. So let me draw it out. So if I have a quadratic, any quadratic, and I want to find the vertex, right? This is called intercept form, which means that it's going to tell us where the graph has intercepts, which means it's where the graph crosses which axis? The x-axis. So the values of p and q are actually where does the graph cross the x. So this is going to be a p, this is going to be a q. Okay, now if these are my intercepts, because the graph is symmetrical, what that means is that the vertex has to be exactly in the middle between p and q. So this is my p distance, this is my q distance, my vertex is exactly in the middle of those two. So if I asked you to find the middle value from two endpoints, who remembers how to find the middle point? Add the two numbers and divide by 2. Find the average, right? If you're 5 units away from a place and the other person's 3 units away, right? How far, what's the middle between the two of you? Well, 5 plus 3 is 8 divided by 2, so 4 units will be the exact middle between you and where the other person's standing. All right, so we're going to take P plus Q, which is the total distance, and then we're going to cut it in half to find the middle. Well, for us, that middle point is going to be the vertex. All right, so we're going to use the symmetry of the graph in order to find where our vertex actually is. So if we come back over here, the x-coordinate of a vertex in intercept form is P plus Q over 2. And again, if you notice, or what's the sign on P in the equation? What's the sign of P at the vertex? So what's it do? Changes its sign. What about Q? Negative to positive, so it changes its sign, okay? If you want to, you can FOIL it all out and then just graph it in standard form. So for the vertex, once I get the x-coordinate, what do I do with the x-coordinate? plug it back in. So I find the y by evaluating my f of x. So the x-coordinate is the p plus q over 2. Once I get the x-coordinate to the vertex, I plug it back in to find the y that matches with it. Everybody all right? When do we get a minimum? When a is what? Greater, maximums are when a is less than, right? Okay, axis of symmetry, vertical, horizontal, or skew. Vertical, so it's going to be an x equals, right? And this time you're going to tell me, what is x going to be equal to? What would I write in here? P plus q over 2. Because the x value for my axis of symmetry is going to be the x value for the vertex. What format is this in? Standard, vertex, or intercept? Intercept, how can you tell? 2 sets of parentheses, okay? So what are my key values for intercept form? A, P, and Q. So what's my A? 2. What's my P? -3, good catch. And what's my Q? +1. So remember, whenever you have parentheses and you pull a number out, you have to flip the sign. So find the vertex. So how do I find the x-coordinate to a vertex in intercept form? P plus q over 2. So P plus q over 2. So what's my P? -3. What's my Q? So I get -3 for my P, 1 for my Q, all over 2. What's -3 plus 1? -2. So what's -2 divided by 2? -1. So that is the x-coordinate to my vertex. How do I find the y-coordinate once I have the x? What do I do with it? Plug it into the equation, right? Now, take a look at my equation up here. How many x's do you see? If there's 2 x's in the equation, how many times am I going to be substituting in my value? Twice, right? So each x gets replaced with my x-coordinate. I always have students who make mistakes with that, so be careful. So I'm going to take my statement to find the y and just replace x with my x value. So I get 2 times the quantity of -1 plus 3 times the quantity of -1 minus 1. Order of operations says I do what's inside the parentheses first. So what's -1 plus 3? 2. What's -1 minus 1? -2. And now I just evaluate. So what's 2 times 2? Times -2. So my y-coordinate is -8. I need to find my axis of symmetry. So again, it's going to be an equation, right? So it's going to be x equals, and which value do I use for my axis of symmetry? Okay, so the x-coordinate out of the vertex, right? So according to my vertex, what's my x-coordinate? -1. So that is the equation to my axis of symmetry. All right, so finish it off real quick here. Make an xy chart. What goes in the middle? The vertex. So I put in -1, -8. I need 2 x's bigger, 2 x's smaller. 1, 0, -2, -3, right? Now, the only thing is that you're going to have to be careful when you substitute here because you have to work each parenthesis separately, then multiply. So when I plug in the 0 here, what's 0 plus 3? 3. What's 0 minus 1? -1. So this becomes 2 times 3 times -1. So what's 2 times 3? Times -1? -6. Everybody okay with how I'm evaluating that? Again, if you want to use the calculator, you're welcome to, but you have to type this statement in exactly the way it looks. 2, parenthesis, 0 plus 3, close parenthesis, open parenthesis, 0 minus 1, close parenthesis. All right, if you use your calculator, you have to make it look exactly like our statement. Otherwise, you are guaranteeing you will get the wrong answer. All right, so plug in a 1. What's 1 minus 1? 0. What's 0 times something? 0. What's 0 times 2? 0. So there you go. Yeah, that one worked out really nice. That's pretty. So plug in -2. What's -2 plus 3? 1. What's -2 minus 1? -3. So what's 2 times 1? 2. 2 times -3? -6. What's -3 plus 3? 0. What's 2 times 0 times something? 0. Everybody okay? Everybody okay with graphing? Right, same old, right? One last thing that we need to cover, and then you'll get your homework assignment. Does everybody in here remember how to FOIL? Okay, what does FOIL stand for? First, outside, inside, last. For the record, I hate that term because it only teaches you how to do a 2x2. Well, what if you have 2 terms and 3 terms? You can't FOIL it. You have to do something else. So what we're really doing here is we're doing the distributive property, right? If I wrote up 5 times x plus 3, how do you distribute that? What do you do? Okay, 5 times the x and then 5 times 3. We're doing the exact same thing here, but how many terms does this first piece have? 2. And how many terms does this piece have? 2. So what that means is in order to multiply these, I have to take every term from the first set of parentheses and multiply it with every term in the second set of parentheses. So I go x times x, first term in the first set times first term in the second set, right? And then I have to take x times the negative 1, first term in the first set times second term in the second set. If there was a number past the negative 1, I'd have to take the x times that as well. Everybody okay? So this is just a giant distributive property. So, and then I take 3 times what? The x, right? Second term in the first set times first term in the second set. And then take the 3 times the negative 1. So I take the second term in the first set times second term in the second set. And I keep going until I'm out of numbers. Okay? So, real quick, who remembers what's x times x? X squared, x times negative 1. 3 times x. 3 times negative 1. Okay, is there anything here that can group up? Okay, so the x's can combine. So what's a negative x plus 3x? Positive 2x, right? So now, if you notice, what form is this equation in? Standard form. So this is like what I was saying to Carly if you didn't catch it earlier. If you don't want to use intercept form, you can FOIL out and get standard form and then graph using the negative b over 2a. Or you can use the p and q up here. I don't care. Just be accurate and be consistent. All right, so here's your homework.